Business Calculus, Topic 5 Homework, Problems 22, 27, 30, and 34. I'm not going to do 33. Alright, okay, we want to take the antiderivative of this function, so I'm going to turn this into powers first. So this will be 6x, and negative x squared plus 9 will be to the 1/2 power. Now, I'm going to treat this as the function u to the 1/2 power, so I'm going to let u replace the negative x squared plus 9. Then this implies that the derivative of u is going to equal negative 2x times dx. Okay, so I'm going to push the constant outside of the root, so 6 here. Then we have x, and then we have negative x squared plus 9 all to the 1/2 dx. And when you see it here, it says to replace all this with u's, you're going to need an x, a dx, and a negative 2. We have a x, a dx, and here's the negative 2. We put that in, and then the reciprocal goes on the outside, negative 1/2. And now, all of this is u, according to this, and all of this, right here, is du. So what we have is the combination here, which gives us negative 3, and the integral of u to the 1/2 power, that's u to the 1/2, and all this becomes du. So the antiderivative of a negative 3u to the 1/2 would be negative 3u, add 1 to the power here, plus 1, so we'll get 3/2, and the reciprocal of 3/2 is negative 2/3, and then plus c makes it indefinite. Okay, the combination here gives us positive 2. The u goes back to negative x squared plus 9, and the 3/2 power becomes a square root and a 1/3 power, all plus c. Okay, once again, number 27. We want all of this right here to be our u. So we'll say let u replace x minus 3. Then du will be replaced by a 1 times dx. Now this replaces the x minus 3 with a u. It also replaces the dx with a du. But the problem is that we don't have anything for the x yet. Nothing here replaces the x. So we're going to use one more setting. Since u equals x minus 3, this implies u plus 3 replaces x. So now we have another substitution for our x here. This x can become the u plus 3. So u plus 3. So let's rewrite all that. U plus 3, u to the 1/3, and the dx becomes du. Now I'm going to distribute my 1/3 here. Remember, this power is 1, so 1/3 plus a 1 gives us u to the 4/3 power plus 3 to the u 1/3 power du. Alright, and now I want to take an antiderivative of this. So this will be u. Add 1 to this, this will become 7/3, and the reciprocal of 7/3 is 3/7. Okay, next. When I add 1 to this, we get 4/3, and the reciprocal of 4/3 is 3/4. And then plus c makes it indefinite. Okay, so this is 3/7. The u stands for x minus 3, so x minus 3. And the root is a cube root, and this is all to the 7th power. Okay, plus, let's see, this will be a 9/4. The u is x minus 3, x minus 3. The 3 is the cube root for the denominator, and the 4 is our power. And all that's plus c. Okay. Next, let's look at solving this, or finding the area under this curve by using Riemann sums. Okay, in order to use Riemann sums, what we're essentially doing is getting the estimate between negative 1 and 1 of the function 11 minus 33x dx. We're trying to approximate the area. Okay, so to do this, we're going to need the summation of the function 11 minus 33x, and we're going to use delta x's, and this is going to give us the approximate area. Okay. Oh, and between negative 1 and 1, and using a total of 4 rectangles. Alright, so let's go after our delta x's first. The delta x's will be the base. So delta x, the formula is b minus a all over n. Well, this will be 1 minus 1 all over 4, and this will be 1/2. So the delta x is 1/2, or we can say 0.5. Alright, so next we need to know what our x's are. Since we have 4, we need x0. Oh, sorry. The formula is xi equals a plus I times delta x. This will give us our x's to put inside for those rectangles. So 0 gives us negative 1 plus 0 times 0.5. And that equals negative 1. Next, this will be negative 1 plus, let's see, I is now 1 times 0.5. And that'll be negative 0.5. x2 will be negative 1 plus 2 times 0.5. And that will be 0. And x3 will be negative 1 plus, let's erase that bit, will be negative 1 plus 3 times 0.5, and that's going to be 0.5. So here are x's. We'll take those x's and put those inside the function here. So f of negative 1, f of negative 0.5, f of 0, and f of 0.5. Okay. Once we get those answers, we're going to add them all up. This is supposed to be a summation down here if you barely read my writing. Alright, so when I put a negative 1 into the function here, I'll get 33 plus 11, that's 44. When I put a negative 0.5, this gives me half of 33, which is 16.5, negative 16.5, and 16.5 and a positive 11 is going to be 16.5. Sorry, calculator. 11 minus 16.5 is going to be negative 5.5. Oh, it's positive, so that's going to be adding, sorry, that'll be 27.5. With 0, that's going to be just 11. And with 0.5, let's see, that's going to be half of that, which is, it'll be 5.5. Okay, we're going to add all these together. 44 plus 27.5 plus 11 plus 5.5, and that gives us 88. So this will be 88. This is the height times the base, which we already determined to be, there is 0.5, which gives us an area, approximate area of 44. Okay. Alright, once again, we want the area for 34 and the area between negative 3 and 3 of the function e to the negative x dx, approximate area. Okay. Let's see here. So we want the summation of the function e to the negative x times delta x. This will serve as the height when we put the x's in here, and this will serve as the base. So base times height will give you actually the area of each rectangle, and we'll add them up, and that will give us the area underneath the graph. Okay, so, and also we know that we want between -3 and 3, and n this time equals 3. So, delta x. Delta x will be b minus a all over n. Notice how I'm writing this down each time. It helps me to remember the formula, because we don't want to get stuck on a test and can't remember this thing. 6 divided by 3 is 2. So our delta x is 2. That's the base, okay, of each rectangle. Now, the formula for this one is a plus I delta x. So the first one will be -3 plus 0 times 2. And that's going to be -3. Then x1 is going to be -3 plus 1 times 2. And that's going to be -1. x2 is going to be -3 plus 2 times 2, which is 1. And I think that's it. Oh, okay, only need 3. Alright, so let's go put these into the function. F of -3, and we need f of -1 and f of 1. Okay, I'm going to pop these into the calculator here. I'll press y equals, clear this, and type in my e, second function e, raised to the power of a -x, close. Okay, hit trace, and then we'll see. Well, let's straighten up my window. Let's go to zoom 6. All right, and now I'm going to input. I'm going to trace and input -3. Oops, something happened here. Let's go back to the equation. Trace, type in -3, enter, and I get 20.086. -1 into the function, I get 2.718, and put 1 into the function, I get 0.368. Alright, I'm going to get the sum of that. The sum of this will be, let's quit here, 20.086 plus 2.718 plus 0.368 gives me 23.172, and then multiply it times my base, which is 2, so times 2. That gives me an approximate area of 46.344.